So Adisha and I are going to start off. Adisha, do you want to introduce yourself? I can just flip the slides.
Hello, friends. Welcome to this session. My name is Aditya. I work as an engineer in the Alliances Group, primarily responsible for validating enterprise applications on our platform from a performance standpoint. Our today's session is about some best practices for deploying network-intensive application on VMware View. This disclaimer, you're familiar with this by now, I guess. This is the last day, so
we can skip it real fast. I'm sure you've seen it in every presentation throughout the whole week.
Just to summarize what we do, this is a snapshot of some of the partners that we have worked with in our labs. Typically what we do is we get their applications in-house in our lab, we virtualize them, we apply some workload against it, which is representative of an end-user case scenario, and we measure performance from an application and an infrastructure perspective, find out bottlenecks, and find tunings to resolve those. All of this mostly goes into a deployment guide, which is mostly public interfacing document available on the internet. And this project and this session is a result of one such project. So for now, I'll let Ken drive the first part of the session, and I'll talk to you guys a little later.
Great. Thanks very much, Adisha. Hi, everyone. As Adisha had mentioned, this is the session is based on a validation effort that we did with a financial application. And my name is Ken Brady. I work in the ISV application group as a technologist in our technical enablement and evangelism group. And I've been at VMware for about 5 years now. Worked at NetApp in the past. I used to be a systems administrator for Adobe. I've got a lot of background in IT infrastructure and storage, networking. For my first 2 years at VMware, I was in sales, and the last 3 I've been working with partners in both the infrastructure and application spaces. We did a session, or a validation, I should say, with a really, really large financial application back in March. And I can't name it. They've asked me not to name the application. This application has about 200,000 customers worldwide. It is in both in use at small home environments as well as large LAN environments. How many people think today that, or consider that they're running a network-intensive application on a View desktop? On the View desktop, yeah. So maybe it's vSphere. And what we did with the session, or with the validation we did, we took it from running in vSphere as an enterprise application, and we pushed it out to the desktop. So the question I was trying to get a handle on in the audience is, how many people are doing more than just running Office applications on View? Okay, a couple of you. How many people want to be able to get there to run that more I/O intensive application in the future? Maybe we're waiting for 4.5 to launch, waiting for the next rev of CPUs from Intel. Well, that's our goal too. We really wanted to take what we learned and observed from the validation work that we did and share that with you to really enable you guys to push the limit and to get those additional, challenging applications deployed on the View desktop. We're going to be talking about a couple different sets of best practices. The first one, I'm going to be talking about the network, building the infrastructure, building the stack, ensuring that the stack is sound to get that optimal performance in the application. Adisha is going to then talk about the observations that we made in our ISV application lab, and the recommendations that we're making to you guys. How many people heard that we launched vSphere 4.1? and soon, I think in a couple days now, 4 or 5 of Vue. There's a lot of great features in there that can help with pushing the performance of an application even further. And then we're going to be talking about PC over IP and some special tunings that we can do that are under the hood that you might not be aware of that can allow you some additional performance. And then we'll wrap it up and we'll have Q&A. But the first thing I wanted to talk about is really just addressing at a high level the problems that the customers are trying to solve. And number one, it's supporting the users who are either they're reluctant to give that desktop or laptop away to the Vue admin. And there's a couple reasons. There could be, hey, the application ISV won't support running it on VMware. Number two, we're getting a lot of requests from IT directors and management to really lower that cost of managing the desktop. So let's peel into this a little further. And I won't spend too much time. How many people have been to a Vue session this week already? Okay, so most of the room, I'm guessing, have seen this slide, everyone? All right, so I'll go through it real quick. I think it's really pretty important. What I didn't realize, and I guess I hadn't really thought about it, that most people are using cloud applications. If you use Gmail, if you use Flickr, Facebook, keep going, Salesforce, iTunes, it's all in the cloud. But what happens when we get to work, that experience we have to leave it at the door. We can't have that 24/7 access to our applications that we're used to at home, used to being able to check email while I'm driving to work or at dinner or whatever. We can't generally do that with our work and our work applications and data. And in addition, we're getting a lot of, as I mentioned, pressures to adhere to the budget, deal with security compliance, et cetera. So what VMware and the end user computing solution enables you is to bridge that gap between your users who are used to having their applications whenever they need them and now allowing that same access with Vue and Vue desktops and the applications at work that you're all managing. Well, so how do we get there? There's, as we heard from the keynote, from both Rick Jackson and Paul Merritt, it's all about the journey. And there's 3 steps to this journey. We've got the step 1 at the bottom of modernizing the desktop. And that's, I think, for the most part, if you guys are already running Vue, that's checked off. The second part is introducing legacy applications, maybe software as a service applications from Salesforce, and integrating those together. And then the third is really, now that I have all this working, to put an SLA to it so I can actually ensure that all these applications are available and accessible. But this isn't just unique to financial, but it's across all sectors, telecom, healthcare, manufacturing. Using voice over IP applications at the desktop level with a smart or soft phone, or with healthcare being able to access a radiology image, manufacture and be able to get access to your visualization application showing the status of the manufacturing floor. So what are the products that address it? It's VMware Vue at the top with vSphere 4.1, at the bottom with the Vue clients or the thin clients. How many people have seen the Wise booth and the Samsung booth on the floor at the Solution Exchange? The improvement and the packaging of PC over IP protocol with those devices is just getting better and better every show I go to. The software IP, the software instance of PC over IP, I should say, is improving with every release of VMware, whether that's running from a thin client, a desktop running Windows, or a laptop. In the middle is VMware View. It's VMware View Manager, it's Composer, it's ThinApp. We're not going to be really talking about ThinApp or really Composer in today's session, but it's the very, very powerful portions of the product. And if you guys haven't looked at using both ThinApp and Composer, you really should take a look. It's very powerful. It's a way to provide additional abstraction of your applications for ThinApp, as well as saving a lot of storage and flexibility. Okay, so let's get to the best practices for the networking. We're gonna talk on kind of the 4 layers here. The first one is really the networking layer. Before you really ever start optimizing for an application, you got to make sure that the underlying stack can really meet your needs, and that's fundamentally using server class network cards, making sure that your NICs are set to auto negotiation, and ensuring that all the physical points, the routers, the NICs, the switches, are all set to full duplex. At the virtualization layer, running a network-intensive application on a physical server takes a lot of CPU cycles. Same thing applies for running in a virtual machine. So you got to make sure that first of all, you have enough CPU utilization available for your VM and your host OS or your host to really allocate what the application requires. Secondly, and it might be fundamental, but make sure that your service console, your VM kernel, your virtual machine network are all separate. If I order just a standard server from HP, for example, a Blade server, and I don't add that quad port NIC, guess what? I'm going to get a server with 2 physical NICs with it. Can't really work with virtualization that well with that. And if I take the defaults, the service console and the VM network are in the same network interface. So make sure when you're ordering your hardware that you get enough network interface cards physically to accommodate all the additional requirements for virtualization. And that leaves you with, for example, if you got 6 NICs on a Blade server, that gives you 2 interfaces for virtual machine network traffic, 2 interfaces for VM kernel, and 2 interfaces for the service console. And then this is more of talking to enterprise applications running on a vSphere, but it also can apply to View. If you have similar applications that reside and talk to each other, you can locate them on the same virtual switch, and the TCP traffic doesn't have to go over the network and back. Okay, at the host OS level, with the release of vSphere 4, VMware introduced VMXNet 3. How many people are still running older than ESX4 as a vSphere or as an ESX platform? Okay, a couple of you guys. You should really think about upgrading, not just to leverage the additional management features, but for the networking portion of VMXNet 3. It adds a tremendous performance increase with a paravirtualization driver that you will see in some speeds and feeds with. Finally, if this is available to you, so leverage jumbo frames. Jumbo frames can be enabled at the guest OS, at the virtual switch layer, and can really increase the packet size that carries your workload and payloads back and forth between your applications and servers. It's important to make sure that all the hops between are all running jumbo frames. And then finally, at the PC over IP layer, this is the protocol that allows the endpoint to connect to the virtual machine in the data center, And it can very much be used as is, right out of the box. It's very fast. It adapts both to high latency and lower bandwidth, but also there is a lot of things that you can access through the group policy. The test that we did during our validation, we used a couple different protocols, and we found that for the best performance, use the hardware-based PC over IP devices. And Teradici actually has a list, and is growing in every release that they're doing of their firmware and their devices, of all the certified devices that are available for VMware View to leverage. And so example here on the right, we've got a Samsung monitor, we've got a Wyze thin client. Both the Samsung and the Wyze devices have support for 2 monitors. For medical, manufacturing, healthcare, financial, for those type of use cases that require more than 2, the Amulet hotkey device actually has support for 4 monitors. So that's the end of my portion of the talk. We'll both be around for Q&A. I wanted to hand it over to Adisha to walk everyone through what we did in the validation lab. Thanks very much.
Thanks, Ken. So getting to the lab piece of our activity, I want to, on this slide, talk about the nature of the application we are talking about in this project and why do we consider it as network intensive. Now, this application streams a massive amount of data, and that's delivered to the desktop. Now, what kind of data are we talking about? Since this is a financial application, there are graphic-intensive charts. There are continuous rolling numbers from a currency chart based on the latest transactions that are happening. There is multimedia, there's audio, there's video, and there's live news available. What implication does this kind of data have on a virtual or a hardware resource is that the quantum of network data that you're driving through your setup is too high. It's not just about the quantum of data, but it's also about the latency of the data. Since this is financially sensitive data, you can't incur a lot of latency because the decision making has to be time bound, and you can't get this data late. Moreover, that we are using remote desktop over here, which means you're adding to the latency for the end user to consume that data because it has to go through another piece of network. And if it is graphic intensive, then that last piece of transfer is also expensive and causes extra latency. So based on these characteristics of the application, we consider what the application that we have worked with to be network intensive, and hence the best practices are around this kind of applications. So the use case that we tested are primarily more common, both the LAN and the WAN use case. In the LAN use case, there's a typical data center, mostly 1 Gbps network around it, and the consumer or the end user is in the same network, most representative of most corporate environments. And this application has relevance in the WAN use case too, as in the example that's highlighted there. For example, for a trader who's on the West Coast who's using a VM over View to access the same application for his financial activity. Now, how did we test the WAN situation in our project? We used a tool called WAN-EM, as in WAN emulator, and it's a pretty good tool. It's got a browser-based interface using which you can configure it. You can inject certain amount of latency, you can control the bandwidth, and that kind of thing. We use this tool. I'll talk a bit more about it when we get to the architecture of the setup. And I want to note that in the past, when this application was tried out on previous version of the View platform, essentially which didn't have support for PC over IP and stuff like that, the performance was not that great. But this time around, it's a different story. So this is the architecture of the test setup. Let me go over some of the things here quickly. We used an HP Blade G6 running Intel Nehalem chips. This is a dual-quad machine. We used a NetApp fiber channel storage array. And this pieces of hardware, so we used a Samsung monitor, which is essentially a zero client with a Teradici chip built into it, which we used for our hardware-based PCoIP testing. We used a Wise terminal for the software piece and software PCoIP testing. And to test through the View client, we just used our laptops. So those were the hardware pieces. We used View.4.0.1 of View. This was the latest version in the February-March timeframe when we did this project, and so is true of the ESX platform. This is the Windows XP VM that we virtualized. This is running the application under consideration on the vSphere platform. And this new cloud is where WAN EM was introduced. So WAN EM essentially is available as a Linux ISO. We put it in a virtual appliance, and we configured the network such that by changing the routing tables on the Windows XP VM, we forced packets that are getting out of the VM towards the client. We forced it to go through the WAN EM. So all the latency that was injected using WAN EM was impacting the packet, or the display packets moving between the XP VM and the clients. Test cases. We're going to be discussing what we tested and what we found, but just before that, I want to acknowledge a limitation over here in that we don't have quantifiable data to report graphic quality. There are various pieces to our testing, and graphics was one part of the testing. And as you may be aware, measuring graphic quality is a challenge in itself. Adding to that challenge is doing it in a remote desktop environment. At VMware internally, we have developed some tools which uses watermarking technology to measure that kind of graphic latency and clarity. But unfortunately, the tool is not yet adopting to third-party applications. It works with a set of applications that we have already programmed it to work for. It's on the roadmap that it needs to work with third-party applications, and we'll get there. So our assessment of graphics was subjective. It was not quantitative. And for this reason, we had our partners who own the application come to our labs in Palo Alto and verify for themselves if this quality is acceptable to the users. Our first testing was about basic functionality, which essentially means in a financial world, looking at the live charts or all the multimedia news so that you're up and current with what's happening and you can take your decisions, looking at those rolling numbers and various other financial commands in the application. And our observation is divided based on protocol. So our project was not about studying differences between display protocols. That was not our goal. Our goal was to understand what does it take to get the application to work, this kind of an application. What does it take to get it to work? And we started off with RDP. That's the common protocol most people are using, or used to at least. And most of the application worked fine, except that the quality of video was not very acceptable. Then when we tried out software PCoIP, there was a major improvement in our observation in the way the application worked. Everything worked very fine, except that when the videos were full-sized to maximize the screen area, there was some pixelization. And you can clearly find out, you can say that this is not as good as native. But other than that, every other functionality worked fine. The video worked exceptionally well in the default size of the video. But when we tried out with the hardware client, in this case, the Samsung client, the results were amazing. And video, audio, rolling numbers, charts, the ease with which the charts move on the screen, there's no responsive problems, there's no latency issues, was absolutely excellent. Moving to the second piece of our testing was around peripherals. Now, this application comes with some peripherals like a custom keyboard. It's not the regular keyboard that we use on a day-to-day basis. They have certain hard-coded specific commands on the keyboard such that you don't have to type out the commands. That saves time and you can get the information you want more quickly. So we have custom keyboards, and we have fingerprint scanners built into the keyboards for easy authentication. And for remote access of the application, there is a biometric device which just looks like a credit card, and it's twice as thick as your credit card. That's it. And it is critical for the application to be adopted on View that these peripherals work, and that was the focus of our testing in this second set of testing. So the finding was that getting this remote devices to work, especially the USB component, was not very straightforward. And we learned through our pains that we needed a specific version of our software to get it to work, which was specifically designed for handling remote USB cases, and the build number is identified over there. Then the other steps were getting a USB controller into the VM and obviously device drivers from the vendor, because this device was specifically designed for custom application and the generic drivers didn't work with it. So those set of peripherals worked fine. That was good. Getting to the biometric device obviously had a window where you could put your finger and it would scan it, but it also had an optical window where it accepts flashing images from the view screen to synchronize and authenticate you. Now, it is critical that this optical window could understand the flash on the screen, the rate at which it's flashing, such that it is as good as a native physical environment like a desktop or a laptop. And that was our focus of testing over here, and our observation was that it worked very well. The next focus of our testing was around display. And we felt that we should not only test the components of the application from a display perspective, but something like Flash. And to do that, we used a website, as mentioned here, like a tilt viewer website. It's a pretty cool website that has a lot of graphics. And as you keep moving your mouse, the graphics move in different directions continuously. You can zoom in and zoom out at a fast rate. So the idea was these are HD images that are changing rapidly on your screen, and you want to see if they refresh soon enough or you see a lag. And our observation was that it was pretty good. It was as good as 85% of a native desktop or a laptop. Multi-monitor. As Ken pointed out, most people in the financial world like to use multi-monitors to have a lot of information on the screen, and this was important to be tested. So we started testing with the software version of the PCoIP client using a laptop, and the results were similar to the past. So multi-monitor obviously worked, but again, in the full screen mode, there was some pixelization, which went away when we tried out with the hardware version of the Teradici PCoIP. This is getting to the WAN piece, getting to latencies and its impact. So what we have on the first column over here are things that we tested, areas of impact. On the second column, what we have is latency numbers. And those are latency numbers under which the application works seamlessly. So even 125 milliseconds does not impact the basic functionality of an app. It does not impact the way you use the keyboard or the responsiveness of the keyboard and the other functionality there. And the last column over there represents that amount of latency that is enough to cause problem, or at least you can perceive a problem. So for example, let's take the fingerprint scanner. Beyond 250 milliseconds, what would happen is if you try to scan your finger, it takes about 3 seconds to authenticate you. It shouldn't take that long. It should be less than a second to authenticate you. And if you increase that number to maybe 500 milliseconds, it would say device disconnected. So the USB device loses connection with the VM because 500 milliseconds is enough to break the connection in the USB protocol or whatever. So 125 milliseconds, it worked seamlessly. And it turns out that recent numbers published by AT&T for average latencies around the globe, 125 milliseconds is enough between San Francisco and London. Most of the numbers are around this. So we're talking about very large-scale WAN deployments that fit very well within these latency numbers. vMotion. Obviously, the focus of our testing over here was to find out what if a network-intensive application like this, when you're using on our platform, and you're using something multimedia, you're looking at a video clip of the news or whatever, what happens when you vMotion them? And our observation was that it worked absolutely fine. And the VM got migrated within 30 to 40 seconds without any impact on the end user, especially in the video use case that I mentioned. So what are some of the best practices that we use to get this to work? Obviously, for any application to work fine, you need to begin with a good set of hardware. And we used Intel chips, basically the Nehalem series, which has hardware virtualization support. They went GA with this sometime around last year, and it has been an amazing processor as far as virtualization overhead is concerned, because a lot of the complexities from the hardware, from the software has been put into the hardware, so it's just better. AMD has equivalent technology. It's called AMD V and AMD RVI. I forget the names of the chips that have in the AMD series. I think it's Shanghai or something. But use of right hardware is critical to success, and NHILM is the way to go, or using chips that have hardware virtualization support is the way to go. Storage is usually a big piece of Vue deployments because large-scale deployments need good storage. And we used what we had in our labs. This was NetApp fiber channel storage over 16 disk using RAID DP, which is NetApp's language for RAID 6, essentially. This was enough for our workload, but typically in your deployments, you would have to consider, based on your capacity requirements, what's the right storage for you, what's the bandwidth you need, what latencies are you expecting. For our use case, this was good enough. Using the latest and greatest then version of Vue and ESX with the right build was critical to our success, especially to get the USB to work. Obviously, with 4.5 Vue just a few days away, that would be the next thing to try out. The firmware on the hardware devices. Now, it turned out that to get the USB devices to work fine, you needed some support from the firmware on the hardware side too, from these client devices, and we were not running the right version of the firmware, and the USB was just not working. That needed a reflashing of the firmware, and the build 250, which was the then latest in the February-March timeframe, was the most suitable one to be used. The then latest version of the G8 platform. Obviously, since Vue 4 builds upon the ESX 4, which has enormous scalability and performance enhancements, you can leverage a lot more features. And it's not ideal to go with 3.5 at this stage. Now, focusing on the Windows XP VM itself, where the application is running, there's a fair bit of things you could do around here. I'm going to talk about a few and let you read some of the others. Simple things like getting rid of devices you don't need, like COM ports. Devices that you don't need still consume interrupts, which still consume CPUs. Why do you want to waste those CPU cycles on devices that are not relevant for you? So you need to take a look at that and get rid of such things. The use of right virtual adapters, in this case LSI logic, because it's a little more efficient than our version of the bus logic that we have, and the right version of VMXNet, like Ken pointed out. The other set of best practices relevant for the same Windows XP VM running the application are these. And the one that I want to highlight are around the visual themes, like very complex screensavers that are heavy, rich background wallpapers. When you have such rich images on the screen, all these images have to be transferred from the Windows XP VM to your thin client. That consumes your network bandwidth. If you have 1,000 users just playing screensavers, you're choking your bandwidth, sending information to a thin client that's not very relevant. So use the way you want it, in the sense that if you really don't care about a screensaver, then get rid of it. But if you want it, then capacity plan for it. Have enough bandwidth for it to be transferred over. And that's an important piece. Okay. So what we accomplished in this project in March was with Vue 4.0.1 and ESX 4.0, right? And right now, we have more recent versions of our products. It is interesting to see what are some of the performance enhancements in these newer versions. I don't want a deep dive session into these new products because there are other sessions covering that in detail, but I would just want to highlight 3 or 4 points that are relevant to our discussion. What is it about these new releases that are improving the performance, and what implication that has on the kind of applications we are talking about? So there's a whole bunch of improvements in 4.1. I just want to focus on 2, one being scalability. In case of scalability, with the new platform, you can have up to 10,000 VM pods. That's a very large deployment of Vue that you can have. But from a performance standpoint, I want to focus on the vCompute aspect, especially around memory compression. Now, what is memory compression? Why is it relevant? Why does it help performance in Vue case? Now, as you may be aware, we have a few memory technologies in our platform that helps us save memory utilization. You might have heard of transparent page sharing, memory ballooning, and the worst of all, the swapping, which goes out to the disk. Now, memory compression is something that happens before you take the extreme step of going out to a disk in the swap activity. What we do is, if we are running into host pressures, if there's an overcommit situation, we just compress the memory such that we occupy less memory on the physical RAM footprint of the host device. And this compression and decompression of memory activity is a nanosecond kind of an activity, and which is much better than the swapping out to the disk, which is more a millisecond kind of an activity. This has resulted in some tremendous improvements, as much as 40% improvement times when you are testing bootstorm in view environments. 9 a.m. in the morning, when hundreds of employees turn on their VM, the bootstorm situation results such that if you have a Windows VM likes to touch every byte of its memory when it powers up. So if 1,000 VMs try to do that on an overcommitted host, that's a significant challenge. And this memory compression technology helps you. The second improvement in the platform, as far as View is concerned, is with powering administrative activity of your VM. Like powering on your VM is 3 times as faster, and creating a virtual machine is almost 60% as faster. And the last piece over here is around network. We've introduced async transmit in the network, which has resulted in View efficiency improvements of about 8%. So 4.1 is power-packed with a lot of performance features, and these 3 are very relevant to our discussion. So that's why we discussed those. What's good about 4.5? Of course, the large scalability. But other than that, the key part, the way I look at it, is supports the new platform, ESX 4.1. And what that means is leverages all the great performance features. The one I want to speak right now is about storage. We introduced some new primitives in vStorage APIs in ESX 4.1 such that heavy IO-intensive operations are no longer carried out by the host. It can just be offloaded to the array. So if you are cloning a VM, which is essentially a copy from point A to point B, the host need not copy it. It can be offloaded to the array. The array vendors need to upgrade their firmware to adopt this technology, and our partners are working towards that. I don't know their release schedules, but that has a tremendous impact on performance. I think there's a demo in the EMC booth where they show the power of this new storage capabilities. Some other enhancements around performance is reduced locking and synchronization overhead, so you can accomplish more in less time and not waste time in locking activity. So we have observed that in this project, a key part of our success was because of PC over IP. And I felt we should spend a second or two and discuss what is PC over IP, why it is good, why it is unique, why it is sort of better than RDP, and what controls and powers you have as an user of a PC over IP technology. So the unique thing about PC over IP is PC over IP was designed just to handle the remote desktop case. And since it was designed with this view in focus, its design considerations take into the design considerations are that we are aware that graphics are a large part of view deployments, and how do you get a lot of graphics transferred over the network and still be responsive. So PC over IP can identify different components on a screen. It can identify a video image, it can identify a photograph, it can identify a text image on the screen. And since it can differentiate and identify different components on a display screen, it uses different compression technology to compress those items, which means you can accomplish greater compression ratios when you use this differentiation approach rather than taking the whole screen and compressing it using whatever one technology. That's the huge advantage. The second advantage of it is PC over IP uses a concept called a progressive build. What does that mean? In progressive build, what it does is it does not try to render everything about that graphic image in one go. What it does, the first version that's loaded on your screen is a lossy image, which is highly compressed. Lossy in the sense it does not have all the information as in the original graphic, but it has enough information for you to interpret what's going on, so that you're more responsive. And all of this is compressed images, so you didn't consume a lot of bandwidth to get it here. And as this image stays on the screen for the next few milliseconds, it updates it with the next packets, progressively builds towards a lossless image. That's the idea. The third aspect about PCoIP is adaptiveness to network. It's able to understand congestions in networks. It's able to understand latencies in network. Because it's able to understand this stuff, it does not clog the network. If there is less bandwidth available, it will go for an option of losing some of the information, like getting a lossy image sent to you first, so that at least you can get going with your activity, and then with the round 2, it will make it more clearer for you. The last piece, which is very cool about PCoIP technology, is WAN optimization is built into PCoIP. So let me take an example. Let's say you're using any application that uses, say, TCP/IP protocol. TCP/IP works on an acknowledgement basis. And most WAN accelerators designed out there what they do is they try to spoof the ACK. By doing that, they give you the impression that the end device has already ACKed you. And because the acknowledgement has come, you can go ahead with the processing. Now, since PCoIP is completely based on UDP, there is no ACK mechanism and there is nothing needed to be spoofed. So you don't really need a WAN accelerator to get PCoIP to work better. The second thing about WAN accelerators is they typically compress the content on the network so that you don't use all the bandwidth. And the compression that they use the ratios they achieve is about 2:1. They can't get to higher compression ratios because they cannot afford to lose information. The compression that they do is of type lossless. But because PCoIP was able to identify different components on the desktop, it could identify this as a graphic, and you don't mind if you lose a few pixels here and there. It can use lossy compression and achieve compression ratios of 100:1. That's why you're consuming less bandwidth to get the same job done. So these are some cool things about PCoIP, and that's why the technology works. And what are some of the controls and powers given to you as a user is that, so by default, it's configured very well in terms of the parameters I'm going to discuss now. But if you are a high-power user and you want more control over it, with the inclusion of GPO settings, group policy settings, when you install View 4.5, you do get a ADM file, which is an administrative template of GPO, and using which you can control these parameters, something like bandwidth. What if you have limited network bandwidth, about 5 users using the same network, and one user is using a lot of multimedia and using a lot of that bandwidth? The other 4 users are just starving for network bandwidth. So you can control what users can use, set a max limit such that they don't clog the network, and the resources are fairly divided for everybody. On the other side, there's a min limit that you can set. If there's a network congestion algorithm that's throttling the bandwidth for your VM, you can set a min such that you don't see the downside of that throttling. So similar stuff is available for adjusting image quality. If your end user experience is not consistent, you can control the image quality so that compression of certain type, of certain lossy nature will be built and the image quality will be stable for you, consistent. Extending that concept to MTUs or maximum transfer units for your network, transmitting large packets over the network is less expensive for operating systems and for virtual machines because you have lesser interrupts to deal with. So if your network has end-to-end support for larger frames, you could change the frame size to send larger packets. By larger packets, you will send lesser of such packets, which is more efficient. So let me try to summarize what we have learned so far. We took a complicated application, and with a version of our platform that was available in March timeframe, we successfully virtualized it. We saw that the newer platforms are much more capable and much more powerful, and that PCoIP is a key part of this success. So I would encourage you to try out such complicated applications that are performance intensive on View, and you can feel free to reach out to us in our ISV labs if you think that your partners who are selling software to you are not supporting VMware just because of a performance reason. Because in our labs, this is what we do. We get applications, we get them to virtualize, and we find out how does it perform, or what does it take to perform well. We do validations in the time frame of 2 weeks to 4 weeks, which is our full-fledged validation, versus a smaller validation which can be done in a day, which is the Ready Logo program. or we can also deal with corner cases, customer escalations if you experience. So you can reach out to us using the URL mentioned over there, and we can work with your software suppliers to work on the performance aspects. So in conclusion, the 3 takeaways of the session as far as we are concerned is that you can virtualize performance-intensive applications, network-intensive applications if you follow certain best practices on good platform. That I want to encourage you to push the envelope. I want you to try complicated applications at your end, and you can always reach out to us and engage with us in our labs if you need help. With that, I want to thank you for attending this session and open the floor for some questions. Ken and I can take some questions, and after that, we'll be available. We'll be around here if you'd like to chat with us on a one-on-one basis. Sir, please go ahead.
I have 2 questions. The first one is, during your testing, can you hear me?
Yeah.
Yep. During your testing, how many virtual machines could you run on a hardware platform you were actually?
Good question. So this phase of testing was phase 1. And in phase 1 of testing, we started with just 1 VM. The reason for doing that was that in prior attempts when working with older platforms was that even 1 VM didn't work for this kind of an application. So we wanted to see if at least 1 VM works, and our finding was that it does work. Our phase 2 of testing is planned with Vue 4.5, where we want to see how many such VMs we can fit on a hypervisor. And that's mostly a capacity planning exercise to see you need so many CPUs, you need so much memory, and so much bandwidth to get it to work. So that was not the focus right now, but in the next few months, that's the focus.
Yeah, and we're working with the ISV to do that both in New York and London on really high-end production systems, both on a corporate network as well as over the WAN.
The other question I had was, PCoIP and display protocol, how does it, how does the multimedia audio, say you're using a voice over IP app in which you want to have real-time audio, how does that get prioritized over the text in app and high-intensity graphics app within your session?
How does voice over IP get prioritized over?
The audio needs to be instant because people don't want to have pauses in their voice over IP sessions, otherwise it's unusable.
That's right.
So how do you prioritize the audio component of the communication over the graphics and the text?
That's an interesting question, something that I don't have too much expertise on that because our focus was so much around the graphics area that we focused on that piece. I think we have some telecom ISVs lined up for this kind of validation when I learn more about these kind of problems. I don't know that. We can get some details from our colleagues a little later and have that information for you.
At the router level, though, the networking level, you can actually prioritize the type of traffic. So you could prioritize the voice over IP traffic over PC over IP traffic, and then you get the TCP traffic. So you can do that kind of stuff at the router level to prioritize the traffic that you're looking to enable your users to optimize with.
So is the audio carried in different UDP ports than the PCoIP? Because I thought that PCoIP actually uses UDP between 16 threads.
I think, Ken, his question is about voice inside Vue environment. So voice inside PC over IP packets. And
using a separate phone, sure. Like you can get your switching layer and prioritize traffic across WAN, but if it's actually within your VDI session, then how do you do that?
There was a couple of folks from Teradici in the last session. Anyone from Teradici today that can answer that? It's a great question. I don't know. But we can talk and I can get your contact info after and follow up with you if you'd like.
I think I've heard them say that doesn't really work very well at this time.
Okay.
That they're working on that.
For the testing that we did, as we mentioned, we resized in full screen and watched C-SPAN Senate confirmation, not Senate confirmation, Senate hearing on healthcare. Audio was really, really clear, and we toggled between different feeds with different bandwidth, and really didn't see any or hear any audio degradation.
Did you do any peer-to-peer video conferencing?
We didn't test peer-to-peer video conferencing with the test that we did. That's something that's a feature of the application that uses a webcam. We've had other validations that have used USB connected devices for healthcare and for telecommunications was the one that was leveraging a webcam. It's something that for every release of Vue that we're doing, we're adding additional support and additional drivers to support devices such as webcams. So I haven't tested the webcam feature or a device with Vue 4.5 yet. I know it was one of the things that was top on the list of devices to really enable. Sure, over here.
How much memory and CPU did you allocate to this VM for your
1 vCPU, 1 GB RAM. Bandwidth at what point? How much bandwidth was consumed to show the graphic? So we looked through ESX top, and it averaged around 5 megabits per second. Yes, please. In the LAN case, in the default case, it was around 20 milliseconds or something. Round trip.
Yeah, round trip.
Yes, please.
I'm sure you got this question already. The security server right now doesn't support PC over IP, correct?
Right.
Because I mean, we got a lot of remote users that they're not able to utilize PC over IP because security. You know, you have an ETA when that's going to happen.
I've heard that.
Beta, DC was saying, yeah, but they told us that's the VMware guy.
It's something that they're working on. It was one of the things that they said, okay, we need to ship 4.5. We don't have this completely completed yet. We're gonna put it into a dot release, so it's going to 4.5x release. I don't have a timeline. I think it should be later this year is what I've been told to expect. It's something that we're really very aware of and working very hard on.
So, any more questions?
Okay.
We'll be around here if you need us.
Yeah.